Hey guys, today's Tuesday, April 21st. Today we are going to look at Goal 2, estimating limits of functions at infinity. So before, back in Chapter 1, Section 3, we learned about end behavior. We talked about the right ends and left ends of functions. And remember, the right end is approaching positive infinity. The left end is when we're talking about approaching negative infinity. And we say it either is going up, down, or approaching a number. So let's go over these again. We're going to do an example first together. So it says estimate the limits at infinity. So this first one says estimate the limit as x approaches infinity of the function 1 over x. I already know that this would be my graph because 1 over x, it's a rational function. I know you guys all still have those original parent function graphs memorized, so you know that this is the graph of 1 over x. Also, I went ahead and made a table. So since I'm looking as x is approaching infinity, I plugged in numbers where x is approaching infinity. So I'm going 10, 100, 1,000, 10,000, 100,000. My numbers are getting closer and closer to infinity. They're growing. Now I want to see what are my y values approaching. Well, I see that my numbers are getting smaller and smaller and smaller. I would guess that this y value is approaching 0. And I'm going to double check on my graph. If I look as x is approaching infinity, that's the right end, what does it look like my y values are doing? It looks like it's getting closer and closer to the x-axis, which means that y is getting closer and closer to 0. So I would say, based on my graph and my table, that this limit is equal to 0. Next, I have this function, estimate the limit as x approaches negative infinity of negative 3 over x squared plus 2. So I already drew my graph. You could plot it on your calculator too if you want. And remember, if you see a graph leveling off as it does on this one, this dotted pink line, remember this is called a horizontal asymptote. Remember, this is an imaginary line that your graph cannot cross. So if it cannot cross where y is equal to 2, that's going to be important for our limit. So let's look. As x is approaching negative infinity, because our numbers are getting smaller and smaller and smaller, negative 10, negative 100, it's approaching negative infinity, what are our y values doing? Based on our graph, on the left end of our graph, as x approaches negative infinity, it looks like our y values are approaching 2. In our table, we can also see y is approaching 2. We have 1.97, 1.9997, 1.99999, and the same after that. So since y is getting closer and closer to 2, as I see in my table and my graph, I can go ahead and conclude that the estimation for this limit as x approaches negative infinity is 2. Next, this graph is a little different. I have the left end and right end on this one. So the reason I did this is because there's two things to note. So first, note that you need to be in radian mode in order to see this graph since it has a trig function in it. So once I plugged it in, I see this graph. So we're going to do negative infinity first. So let's see. As x is approaching negative infinity, this time I used smaller numbers just because when I plugged in bigger numbers, it was giving me such a big number that I couldn't even write it out. What are my y values doing? They are getting closer and closer to 0. So they were bouncing back and forth a little bit at first, but this is showing me y is approaching 0. And if I look at my graph confirms this. So my limit on the left side is 0. Now let's look at the right side. As x is approaching infinity, my y values, let's look at it. We have 0, 21,000, 4.8 times 10 to the 21st, so that's a giant number. And then I go back to a really super negative number, -2 times 10 to the 43rd. So I went from a really big positive number down to a really low negative number. Notice on my graph, I'm bouncing up and down, up and down. This is called an oscillating graph. Excuse my spelling, I'm not sure if I spelled that right. On an oscillating graph, my y value is not approaching a single number. It's bouncing up and down, back and forth. So what I would say for this limit is that this limit does not exist because it is not approaching a certain number or a certain value. All right, I have 3 practice problems for you to complete. Try them before you go on to the answers. So pause the video now and see if you can do these 3 practice problems. All right, here are the graphs for these. Let's go over them together. For the first one, we are looking at the limit as x approaches infinity and looking at the right side. So I see that my y values are all approaching -3, and if you check that with your your table, you would be confirming that suspicion. Our y values are also approaching -3. Next, as x approaches -infinity, that means the left end of my graph, I see that it's getting closer and closer to the x-axis. That means my y values are approaching 0. You could confirm that again with a table. And finally, on this one, make sure hopefully you had your calculator in radian mode in order to see this graph. And I know that the graph of sine of x, I didn't even really need to graph that because I know it's just a wave up and down going between -1 and +1. This is another example of an oscillating function. So this limit does not exist. I guess you really shouldn't put an equal sign if it does not exist. That doesn't make sense. Equals does not exist. Doesn't make sense. All right, there are your 3 answers for those practice problems. This one, again, since it's bouncing up and down on the right side, that's why it does not exist. Here's your homework for tonight. You have 4 problems on page 743, and for your daily reflection question, I want you to answer this question. In the next lesson, we will be learning how to find the limits of functions algebraically. I want you to write 1 to 2 complete sentences about how you think these 2 goals, 1 and 2, which we did finding limits graphically and numerically. Remember, we did approaching a certain number, and then we approached -infinity or positive infinity. Tell me, how do you think that will help you with the content in the next lesson? Happy Earth Day tomorrow. It's the 50th anniversary of Earth Day. Hopefully you do something to benefit our environment or get out there and enjoy Mother Nature. Have a great Wednesday, guys. I'll see you on Thursday. Bye.